Welcome, everyone. Thank you for coming to this session. And we are going to talk about AWS PrivateLink here. My name is Tim Lee. I'm a senior product manager of AWS EC2 Networking, responsible for AWS PrivateLink. Today, I have the honor to have Scott, Ran, and Eric to join me as our partners, and they will join the presentation as well. So what to expect here? So first, I'm going to introduce AWS PrivateLink and its benefits and how to use it. And next, I'm going to invite Scott and Ran and Eric to come to the stage to talk about their use cases and how PrivateLink helped them and their customers. In the final, I'm going to give some final thoughts about more use cases and how you may better leverage AWS PrivateLink. So let's get it started. So let's look at what the networking looks like on the cloud. So when you started your networking infrastructure, you may have a few VPCs. And very likely, you have applications in those VPCs that needs to talk to each other. The most common way to do so today is VPC peering. And next, you need to reach to AWS service public endpoints. And the most common way to do so is you use public IP and go to AWS endpoints. You have to reach out of the VPC to do so. And a lot of our customers use AWS as the seamless extension of their on-premise data center. So it's likely you have a AWS Direct Connect between the on-prem and your VPC. The very last, there's a bubble over there called a SaaS. Today, the most common way to reach there is through internet. Well, this whole architecture works for many of our customers. We do hear challenges from our large enterprise customers and extremely security-conscious customers, as well as customers in the industries with regulatory compliance requirements. Let's start with peering. So the peering requires non-overlapping IP addresses, because essentially we are joining two networks together. So this requires IP space planning and the close coordination between teams. Sometimes this is hard, and sometimes this is even impossible, especially in the situation, let's say a merger and acquisition event, you acquired some other people, and their network is likely to overlap with you. And you don't have control. You have to tear down the whole network and establish it back just to align with your IP allocation strategy. As well as since you have to reach out of the VPC, use public IP address to go to the AWS public endpoints, that potentially expose your resources to the internet and increase your risk over there. And lastly, as we talk with a lot of our customers love to use SaaS. However, to send traffic over the internet is a non-starter there. So those are some challenges. And here's AWS PrivateLink. So PrivateLink brings the services into your VPC and your on-prem data center instead of you having to reach out to talk to those services. So back to earlier this month, we announced AWS PrivateLink for AWS services. So these are the services currently available. For those services, essentially, you don't need to reach out to the service public endpoints anymore. You can establish a private endpoint within your VPC, and your application just need to talk to those private endpoints. And the endpoints will automatically forward the traffic to the other side through the Amazon private network. So it definitely doesn't go out to the internet, and you don't need a public IP address to start with. So the endpoint is in the format of Elastic Network Interface, which has a private IP address within your VPC and has DNS name on that. And this Tuesday, we expanded this capability. Now, you can use the PrivateLink to access your own services that's hosted in another VPC and even another account. And you can access our partner SaaS solutions from your VPC using the PrivateLink and using the endpoints in your VPC. So here's how it works on the service provider side. Let's say you are a service owner and you want the service to be shared to other VPCs. You just need to establish a network load balancer and pointing the load balancer to the instances behind it. Then you just register service with that. Now, then after that, you will just whitelist your customers. Now your customers can already establish endpoints in their VPC to connect to your load balancer. So this is a secure way, and this way we don't require non-overlapping IP address here. And as you can see, the load balancer here, usually that's transparent, which means it preserves IP address. With this model, the network load balancer will just rewrite the IP address to make the source IP as a network load balancer IP. So your EC2 instance behind the NLB will always see the traffic coming from the network load balancer. And for those service providers who want a little bit more information of where the traffic is coming from, which VPC endpoints is actually sending the traffic, we provide you a way to use the proxy protocol v2 as it's a HA proxy-based solution that you can interpret and get more information from that. Here's on the service user side. As a service user, as we described, you just need to establish interface endpoints in your VPC. And those interface endpoints has local IP address with it. And there's no route table entry anymore. This is different than our traditional gateway type endpoints, which is available today for S3 and DynamoDB. So for that, you got route table entry, and once you start to call S3 and DynamoDB, we will route you privately through Amazon's private network. Here, you just have a ENI within your VPC with a local IP address there. It's covered by your local route. And the endpoints can span multiple availability zones. As we showed before, you got a network load balancer that can span multiple availability zones as well. So same here with the endpoints. You may choose to do so for fault tolerance and better availability. And each endpoint will have DNS name on that. Those are going to be publicly resolvable DNS names. And you will have regional DNS and zonal DNS, depends on what you want to choose. If you want to use regional DNS, it will just round robin among those healthy endpoints. And the endpoints is NLB health check aware. That means it's bounded with the NLB health check on the other side. Let's say that NLB in that zone gets unhealthy, then the DNS will take that out of the healthy endpoint IPs, and the original DNS will always go to the healthy endpoints. Because now it's an elastic network interface, you can have security group integrated with that. So that helps you to control which instance, which applications in your VPC will be able to talk to which endpoints to get to the services behind it. And as you can see, this model works with the AWS Direct Connect well as well. Let's say you have an application that's sitting in your on-prem network, and you can direct connect to come to the VPC to talk to the endpoints. And the traffic will just get automatically forwarded to the service on the other side. So this is how it looks from end to end. And as you can see, this is a very scalable model. You have a service owner VPC sitting over there with the NLB and the service over there. And you can provide the service to thousands of client VPCs. And you can think of this as like we are providing this service, the service owner VPC can be an Amazon service, such as EC2 API and the ELB API. Or this can be your own logging service, or this can be a SaaS provider. And the client VPC side, you just have your applications and your endpoints. And because we don't require non-overlapping IP address, these side blocks can completely overlap with each other. So you don't have that headache of planning IP side blocks and try not to overlap with each other anymore. And this also shows it works with AWS Direct Connect so that your on-prem resources will be able to access to those endpoints. PrivateLink is deeply integrated with AWS Marketplace. As you can see here, you will have great discoverability on Marketplace and see which services are available over there that's supporting PrivateLink. Another add-on benefit when you onboard the service to Marketplace is we will support vanity DNS names. So here's the base DNS name if you just set up a service yourself as a customer-hosted service. You will have service ID, you will have region, and you will have the subdomain that's underneath AmazonAWS.com. And once your client on their VPC create endpoints, you will see there's a unique VPC endpoint ID in front of the base DNS names there. So as clients create more endpoints, you will just, the DNS, it's just the different DNS entries for all the different endpoints. And here's how the vanity DNS name works. So because now you onboard to Marketplace, we know you, and we can validate you own that particular DNS domain. We can override the DNS, the base DNS, to be the DNS you choose. In this case, it's vpce.myexample.com. And it's optional to put a region there just for your future scalability in case you expand to different regions. And then the endpoints created by the client, it will still have the endpoint ID, but it will be followed by the DNS name of your choice. There are a couple of benefits with this. First of all, it's easier to recognize the service endpoints. You will easily see this endpoint is going to myexample.com. Secondly, this is straightforward for TLS termination. Because as a random service, the anonymous service you host over there, since it's underneath Amazon AWS.com domain, you likely don't have the certificate for that. And you will have to install your own certificate and tell your client to use private DNS, override the endpoint DNS to get to your domains where you have the cert. Here, it's straightforward. Your client will just call the myexample.com domain, and likely you have the cert for that as you control that domain. Another benefit with Marketplace is we can see for each individual service, if we want to create endpoints to it, to non-AWS service or non-Marketplace service, we require you to input the service name explicitly. The reason behind that is because anyone who has a service can whitelist you, and we don't want you to see the polluted results for all the different services. And we want you to explicitly input there so that you are sure you are connecting to that particular service. And for Marketplace services, it's just very like AWS service. You will be able to see these are the services you subscribed to, and you will be easily create endpoints against those services. With that, I'm going to hand over to Scott, who has a Marketplace SaaS solution offering today.
Excellent. Thank you so much, Tim. We're really honored to be a part of this, one of the launch partners of PrivateLink. It really enables us to tackle problems for some of our more security-minded customers that would otherwise be completely impossible. In addition to that, we're also really happy to be named one of the AI competency partners early this week. And I'm going to tell you a little bit more about what it is that we do and what PrivateLink enables us to do with our customers. So first up, SIGOP provides optimization as a service. So if you saw yesterday's keynote, you might hear the words like hyperparameters and architecture parameters and things like that thrown around. These are the configuration parameters that make deep learning and machine learning and AI actually work. So these are all the knobs and levers that you need to set before you even go about doing any training. And traditionally, this was a very time-consuming and expensive process. People would either set them manually or via brute force or a random approach, and all of these really don't scale at all. So what SIGOP provides is a simple SaaS solution that bolts on top of these pipelines and tunes them better, faster, and cheaper than other techniques. And the way that this actually works is by kind of learning about how the model responds to different configurations. So this is an example from TensorFlow. You can go to playground.tensorflow.org and play with this example right here. It basically lets you tune a neural network in your browser. So first, I want you to look at the far right. This is the data that the problem that we're trying to solve. We have orange dots and we have blue dots, and we want to learn a surface that is orange where there's an orange dot and blue where there's a blue dot. To put a little bit more context around this, let's pretend that you were doing fraud detection. Every orange dot is a fraudulent transaction. Every blue dot is a non-fraudulent one. And we want to be able to learn ahead of time whether or not they're fraudulent. So one thing that you should notice is there's lots of these little configuration parameters that you would have to set that are completely independent from that underlying data. You could know everything in the world about fraud detection, but but choosing the number of hidden layers, the number of neurons per layer, batch size, learning rate, activation function, these are all just kind of black box parameters. So what SIGOP does is bolts on top of this system and tries various combinations, learning which ones work, which ones don't work. It's exploring different configurations, exploiting that knowledge to drive you to ever better and better results. And this allows you to focus more time on building great models, understanding your data set, and deploying it to your customers, while we handle the nitty-gritty of actually getting them to their peak performance. So how this actually works is via a SaaS REST API. You have your machine learning model in the background, you have your data, and whatever it may be. SIGOP bolts on top, suggesting configurations via a REST API request. You report back how well it did, we learn from that, and continue and converge you to better and better results. And all of this happens via this REST API. But one thing that our customers kind of came to us time and time again was, even though we're not looking at the underlying data or model of the system, we're treating it like a black box that we can just suggest a configuration and observe the result, there's still some information being conveyed. You might be able to see like what types of models they're using, or get an idea of how frequently they were tuning, and that has to go over the open internet. So for our credit card customers, our algorithmic trading customers, and some of them, this was kind of a non-starter. And this kind of forced us to traditionally have to either build an on-prem solution or work to obfuscate things in a way that made it very difficult for us to provide great support. So now with PrivateLink, what we're able to do is take what we've already built in AWS, all these things that our customers know and love and trust, and be able to create this private connection between our VPC that has our entire optimization framework here. And I go into more detail into this in CMP 314, which you can find online now. And instead of going over the open internet here, we're able to say, okay, we're going to suggest different configurations to try in whatever VPC you have, maybe in multiple VPCs. We're going to handle the kind of distributed hyperparameter training. We're going to be the aggregator of all of these different things, taking otherwise serial models and making them parallel by being able to try different things simultaneously. But instead of sending all of this over the open internet, now we can go into this VPC endpoint and then to us. So all of that is consolidated within their side via this hub and spoke model. And so we're working with a large company that has a recommendation system. And this has really enabled them to scale up not only their deep learning system behind it by being able to try many things in parallel without having to write all the configurations and the containment of it themselves, but now they can do it securely as well. But one thing that's really cool, and that our deep learning customers in the financial services industry, like a major credit card customer of ours, really is now we can take things that were historically an on-prem only solution, and they can leverage our fully scalable SaaS solution. So for one of our customers, they had their own internal environment where they ran all of their ML models. That's this on-premise installation here. And SIGOP had to be deployed there. So we took a small version of it and packaged it up in Docker containers and gave it to them. But that wasn't as great because we've built this huge scalable infrastructure on AWS, and they weren't able to leverage it. So now with PrivateLink, they can do that AWS Direct Connect to their Amazon VPC, and then pass that from that secure PrivateLink endpoint into SIGOP. And so this allows them to kind of tunnel through their system in an extremely secure way, so nothing ever goes over the open internet, but they're still able to leverage our SaaS solution. And so now that same customer that was traditionally constrained to that single on-prem installation can leverage the full power of our SaaS solution. And this is game-changing for these customers that need this type of optimization, but had otherwise no access to it and had to use those very inefficient traditional methods of grid search, random search, or manual tuning. And the nice thing is, too, that this integrates on top of any underlying framework. So it could be TensorFlow, it could be MXNet. We just released an integration for SageMaker earlier today. And all you need to do is just bolt this on top via AWS Marketplace and now PrivateLink. So with that, I'm going to hand it off to Ran, and he can tell you about Aqua Security.
Thank you. Thank you, everybody, for coming here and listening to us. I want to know who's the container customer that you're working with. Aqua Security is a company that deals with the life cycle of containers. We see containers growing everywhere. I'm sure that everyone here heard about containers. Most people actually have containers in their environment. And even more so, containers traversing between on-prem and cloud, the AWS cloud. Everywhere we're going and every customer we talk to has containers as the main focus for development, and security is becoming the next thing. With that came challenges that we'll talk about with PrivateLink. Aqua does three things. We start by looking at the packages when they're being built, identifying them, making sure that they're all valid, recent, not orphans, and that no secrets are embedded into containers. We then go and sign those packages and the containers as they're being built in the CI/CD, and we escort them through the publishing process in multiple environments. If you think about a standard process of a customer, then there will be developers building the containers. Not many write containers or the packages, but it's sort of compiling them. That's very often done on-premise. From there, there's the build process, and then the publishing that goes to staging or R&D to staging environments. Those usually run on-premise and then in the cloud, and then they go to production. We integrate as multiple gateways along the way to make sure that the container meets the requirements, the security criteria, and anything else the different parts of the organization require from a container to be before it goes into production. With PrivateLink, we can actually do this all seamlessly for the users as they go, regardless of where it is, on-premise, cloud, and vice versa. I think that the most interesting part about container scanning is that moving the container to the scanning engine is the longest part of the process. And PrivateLink allows us to do it now locally, or what would seem to be locally in terms of how it performs. And considering that many of our customers publish multiple versions, up to tens of versions a day on some of their containers, this is a big change for us. We also, the integration that we did beyond just utilizing PrivateLink as the means to go and the direct connect when it comes from the on-premise is becoming part of the gate. So if a container fails as it goes into a PrivateLink process, and going to the next stage, if it fails the check, it will go right back. So we can stop it before it even gets to the environment that you want to stop it from getting to based on the checks. From there, we go to the second phase, which is the runtime protection, where we look at the containers, we inject secrets, and that's a very interesting another thing that we're going to utilize PrivateLink for, is we are becoming a proxy, if you will, for the secret management or the vault solution of choice, be it on Amazon or on-premise or a combination. And again, customers are very excited. The two customers that we have jointly betaed with, we're very excited about doing all of this over a secure connection that is internal and not exposed, and eliminating the need to go in and out of the cloud. And so what would it look like? Everybody is showing. So we have multiple regions deployed today. We run these scans over there. You can do, customers do either their own scans or scan on demand. So developers can go and do scans randomly, regularly, or become part of the pipeline. With the PrivateLink, we allow customers or random customers who wants to check a container, again, to do it internally within the Amazon environment and not go out. It also allows the transition between different VPCs of the same customer, again, staging our development and production through PrivateLink and through our process as well. Where do we see the customers' benefits from all of this? The first one is the simplicity. There's no more transitioning or transporting containers across different environments in the cloud. Containers today, in the way they move, are not very secure. If somebody captures a container, they don't have disk encryption and stuff like that. So it eliminates an area that is of great concerns to many of the people that we work with. And then once you do it, we can maintain the integrity of that container moving forward. and we only check deltas. Again, the private link utilization will be much smaller after the initial stage as we go and check only the deltas that go over it, which makes it also much faster. Lastly is the ability to say, hey, this cannot go on this link right now. This has to be fixed. There are 2 packages that are not meeting the criteria. There's a password embedded into the code that you need to remove before you can publish it, and so forth. So with that, we sort of streamline the process to make it much faster and more efficient. Again, at the end of it, we see a private link as the vehicle for us to provide a much better experience for the customers as they traverse the different environments they have in AWS or on-premise, and automate a lot of those things. I mean, we have customers with tens of thousands of containers compiling various applications. It's not something that can be managed manually. Private Link gives them the feeling that this is all internal and secure, and it makes things go much faster. And with that, thank you for your time, and I'll let Eric continue.
Thanks, Ryan. Hi, guys. I'm Eric Brown, the DevOps lead at AppDynamics. I kind of want to talk today about how we kind of utilize Private Link to kind of reduce some of the barriers for kind of customer engagements, and also how we can kind of think about DevOps a little bit differently as we've kind of grown up from kind of our small startup to kind of a bigger group now that we've been acquired by Cisco. So what's AppDynamics? We're a monitoring company. We're a drop-in monitoring solution for all major languages. We're doing application monitoring, database monitoring, server monitoring, as well as mobile monitoring. So when we actually drop in our product into your software, we spin up our agents, and we start building a relational map of how your application is performing from the ingest point to the point where it actually gets to your database or S3 or anything. So we can kind of see where the performance bottlenecks are, and also any throughput issues that could potentially happen. So once we kind of get that data, we're also putting analytics on the top of it. So we're also developing baselines for your applications to alert on and to kind of tell you, how is your application performing and how should it be performing. We're also performing analytics to show you how much revenue have you lost from any previous incidents, or is your performance costing you any revenue for your current application. So those are some of the things that you kind of can see when you use our product. So kind of what I wanted to talk about today was when I kind of go into a customer engagement, one of the first things for highly security conscious customers is more asking, how can I transfer my data privately from here to over to your ingestion services? And we got a fairly typical problem. We have all our agents here from each of our servers, and we basically attach an agent to a client server, and we want to send that data over to our ingestion services and then represent it. So this is one of the solutions that, it works. We have a basically on-prem VPN solution here. And I guess when we talked to AWS initially, we were like, well, this works, but can we have something better that might be more scalable and more fluid for a customer engagement? And it also doesn't really take care of the use case where a customer's more in the VPC itself. So we kind of asked them to kind of develop a solution for us that I think makes it a lot easier from end to end from the customer engagement perspective. And kind of internally too, as your kind of teams build out, I think one of the big things that changed for me when I went from a smaller startup to a bigger startup is how teams design their VPCs as well. A lot of teams now kind of have more independence and more, I guess, autonomy. And so they're building out different VPCs and then different microservices. So you can see here, like for one of my examples, our controller, which is our main application, has to talk to our metric ingestion service. So how do you kind of do it now? You do it through a peering connection. So it works, but you can kind of see, like, as you kind of build out more and more microservices, you're going to get more complex peering connections. And the other thing I kind of wanted to present too is on the right side, like, as more teams kind of grow up and you're developing more faster and faster, microservices want to spin up and teams want to spin up things as fast as possible. So they might actually start doing things differently than maybe some of your previous teams would do. So maybe this team, this controller and blitz team are working together and providing a peering connection, but say the analytics team says, well, here's an endpoint for you for the application team. Now you start having differences in your design and how you're scaling as a company. And I think that's one of the things we wanted to avoid. And I think that's one of the great features that Tim kind of went over. So to kind of go over a few of the other issues, if you guys are managing your VPCs, you're probably using CloudFormation or Terraform or some of these other methods. When you're doing a lot of VPC peering, you're managing your seeder blocks. Like Tim said, you're also making your CloudFormation templates a lot more static, and they get more complicated. And you might have 7 or 8 templates, and you don't really need them. You're just having more peering routes for, say, one VPC. And so you can't really do a more generic VPC templating. And kind of what I was saying before, more and more teams grow out of your company. You're going to have more accounts. You're going to have more cross-VPC connections. So you're going to have to think about how you manage those services. And as you kind of grow up, too, security has a bigger focus. You're not the small startup anymore, so you're managed a lot heavier. So we use Evident.io to kind of manage some of our security. And now we know about security groups opening up, security anti-patterns as well. So a lot of the answers to those problems aren't just one-off solutions. They're global design problems. And we have to start thinking about that in a different way. So what does kind of Private Link kind of help us out with? Kind of like I said before, when I go into a customer engagement now, I kind of have a different solution, a much more clear solution I can give to a client. If you have your VPC here, as long as you manage a secure link up to that VPC, now it's kind of going from one VPC to our VPC securely. In the same sense, if I have a customer in Germany and they have data locality issues, I can tell them if you have your VPC in EU Central 1, it's never going to leave EU Central 1. It's going to stay within the country. So you kind of take care of data sovereignty issues as well. And I think that's what we really liked about Private Link. Now a customer can kind of point and click, whitelist their VPC endpoint and their account. And we can kind of start moving in a private and secure fashion. And we're not really losing anything in terms of security. What's also kind of nice, I guess, as a DevOps person, is really starting to, I think, unify a better design pattern for how you're building out your systems and really defines differently how you think about core services. When you initially design a VPC endpoint previously, you would do it for S3 to retain private traffic for your S3 traffic. But now you're kind of defining different core services that are custom to you and what's important to you. So kind of going back to the previous example, now for that controller team, what might be a core service to them might be the metric service and the analytics suite. So they can just add that service and then kind of go on the way and then have a better design pattern for new microservices that might pop up. So what does this kind of look like in practice? So you can kind of see, what do I have to do from my side? I create my network load balancer, and then here's my ingestion services that are connecting to my network load balancer. From that point, I create my VPC service endpoint. I attach my network load balancer to that. And now it's available to use for the customers. So customer 1 can go in, go to our marketplace, find our service, and then that account will be whitelisted to our service. From that point, they can create their VPC endpoint that'll attach to that service. So like Tim said, now you have a DNS endpoint to send this traffic. And so now you can kind of see now all my app agent traffic from this customer 1's VPC can go down to the network load balancer securely and then right to our ingestion services. And so I think that's what I really like about this. It's a very simple solution and a scalable one as well. And I like it from the other aspect of, as a DevOps person, I need some tools and something better than a more elegant solution than what peering was. And I think that's what's great. It's a customer-focused solution and a DevOps solution as well. So that's what I really love about it. So I guess with that, I'll hand it back to Tim.
Thank you, Eric. Yeah. Thank you, Ryan, and thank you, Scott. So I'm going to give some final thoughts on what are the other use cases about Private Link and what are the benefits of that and how you may better leverage AWS Private Link. So here are some more use cases here. So first of all, basically for any centralized service, say it's a centralized DB logging monitoring service, as long as there's a centralized service that you need to serve lots of VPCs, and you have clients just in lots of different VPCs. So you don't have to worry about the peering and overlapping IP address here. Secondly, the microservice implementation is going to be a perfect fit for PrivateLink. Think about you got hundreds or even thousands of VPCs that every team just run their autonomy and build their own service in their own small bubble of the VPC, and that has dependency on quite a few other VPCs. So this is going to be a perfect use case over there as well. Thirdly, if you need to access a SaaS, or if you have a SaaS solution that you want to serve your customers who you cannot serve before because they're worried about coming to you through the internet, then we have a great solution here for that use case. So I want to go through a few of PrivateLink benefits here. So first of all, PrivateLink enables our customers to use the unified stack across on-premise networks as well as the VPCs. Let's say you have a SaaS solution that you are using. Today, in your on-prem data center, you may not be able to use the SaaS version of that. You have to use on-prem software deployed in your own server. And on VPC, you may be able to use a SaaS solution, or you are using a different version of that. Now with PrivateLink, your on-prem networks, as well as your VPCs, can use the same SaaS solution. That significantly simplifies your operational overhead and simplifies your architecture. Next, AWS PrivateLink is highly available and horizontally scalable on both the service side and the client side. As you can see, on the service side, the service is fronted by a network load balancer, which is the new level 4 load balancer we released earlier this year. And the network load balancer is highly available, and it's highly scalable as well. On the client side, you create interface endpoints, and the interface endpoints is also highly available and highly scalable, managed by AWS. It can horizontally scale to a very high bandwidth. And both technologies are powered by the hyperplane, which is the technology that we use to power popular services like NAT Gateway, EFS, now with Network Load Balancer, and PrivateLink. So as we mentioned before, AWS PrivateLink reduces your operational overhead. Now you don't have to worry about overlapping IP space and the planning and the coordination among different teams, as well as you don't have to go through the internet and manage various security devices, such as firewall, NAT, proxy, fleet, all those things. Now, with the PrivateLink, you just need to reach to the endpoints in your VPC and have no worry about anything else after that. So PrivateLink is a secure model. So the service owner, compared with peering, you are not exposing your whole network to your client, which is a pain point for some SaaS provider or for some service provider who want to connect or share the service to someone that's outside of your organization or your company. So essentially, you are only exposing a service concept as represented by an endpoint in your client's VPC. And that's the only thing client can see there. And to the endpoint user, to the service user on the client side, you only create endpoints, and only you can initiate the traffic to connect to the service. Service will only just respond to your traffic. So you wouldn't have to worry about sometimes service start to arbitrarily reaching out to the resources in your VPC. So that model, the client always initiates the connection to the service provider. With that, thank you everyone for your time here, and we can be open for questions. Is there? Okay.
You mentioned that the NLB NATs the source IP, but that's not the normal NLB behavior.
Yeah, that is correct. So for the normal network load balancer, it's usually just a transparent and preserving the source IP address. However, for PrivateLink related traffic, the network load balancer will rewrite the source IP to be the NLB's IP. The reason behind that is because we allow completely overlapping IP address, the application, the instance on the client side who sent the traffic may exactly have the same IP as the instance behind the network load balancer here. So we will just rewrite the IP address as the NLB source IP, so your network load balancer will always see the traffic coming from the NLB.
Is there any special considerations with a direct connect using a transit VPC and bringing those SaaS services through? Is there anything different there to consider?
There's no particular special considerations over there. So if you have a direct connect to one of your VPCs, and you just create endpoints in those VPC, and that endpoints get connected to another service, this will just work out of box.
How is this priced? Is it per amount of data you transfer, or how is this priced?
Sure. So the question is, how is this priced? So on the service provider side, you will just pay your normal network load balancer price as well as your EC2 instance price. There's no additional charge for you as a service provider. On the client side, when you establish endpoints, we have a charge on the interface endpoints, which is the new type of endpoints there. And for that, we charge an hourly rate per endpoint's ENI, and we charge per gigabyte of data processing over there.
Where does one install the SSL certificate? Because NLB doesn't terminate SSL.
So yeah, the question is, when will NLB start to support SSL termination? Okay, so NLB today doesn't support SSL or TLS termination there. So with this model today, the SSL and the TLS termination happens on the backend EC2 instance of the network load balancer. However, we do hear a customer has that request, and we will look into this request and prioritize it into our roadmap. Is there any more questions?
With something like the service catalog and private DNS, how would that work as in the firm's private DNS system, rather than using Route 53?
Can you say again?
So if I'm saying I'm using it for something like the service catalog, and you're creating a DNS name that you could put in a private hosted server, is there a way of getting that to work with the firm's own DNS system?
So the question is how to get the DNS to work with the firm-owned DNS system?
Yes.
So is that particular to the service catalog?
Just as an example, yes.
Okay. So for a company, if my understanding is, if you are, my understanding of your question is, if you are a service provider and you want to use your own DNS names, how does that work on the client side? Is that the question?
No, I suppose it's a lot more if with using these kinds of services, you're assuming that Route 53 is fronting it. But say you're a big corporation, you're used to running your own DNS services.
I see.
You integrate it.
I see. So the question is, what if I'm not using Route 53 on the client side, and how do I get to resolve the DNS names, right? So actually, so the DNS name on the endpoints is publicly resolvable. You don't have to use the Route 53 on the client side. Any DNS resolution, as long as you get to the DNS resolution on the internet, it will resolve to a local IP address. It's publicly resolvable, and it will resolve to a local IP address within, like in your VPC. Let's say it's going to be something.vpce.myexample.com that will resolve to an IP address of 10.0.1.2. And that can be resolved everywhere, including in your own on-prem data center. So that's why this DNS works even you are in your on-prem networks as well as on the VPC. So it's not like particularly using the private DNS host zone here. Sure. So from the private link perspective, the question is how would it work between two VPCs if one VPC just want to SSH into the other VPC, right? So from private link perspective, we just provide you the connectivity option on the level 4 network space. So basically, any TCP connection, as long as it's a TCP connection that's initiated from the client side, you got a service fronted by a network load balancer on the other side. As long as the architecture looks like that and the client initiates the traffic, that can work in general. We didn't have particular idea on the SSH architecture here.
The SSH to a particular machine, right? Not IP address
So,
visible from some of the VPC.
Sure. So the service is not designed for you to access a particular machine on the other side. It's designed for you to access a service that's using multiple EC2 instances and fronted by a network load balancer.
You mentioned direct connect a bunch of times. If you're connecting to Amazon via a VPN, can you leverage Private Link or not?
Today, it's not. But we have it on the roadmap to enable it soon. So today, you can only use direct connect from your on-prem to access to the endpoints in the VPC. We understand this requirement, and we will enable it in the near future.
Is there a way that the service provider initiate the connection?
The question is there a way the service provider initiates this connection? The answer is no for private link. But we are trying to understand these requirements, and we may build other products to accommodate those requirements.
How does the behavior compare to the S3 endpoint? Are we expecting, is it, I'm not quite clear whether it's the same from the client side, or whether they're going to get unified at some point, if they are different.
So can you say again?
The S3 endpoint that you had before
Yes.
Is doing a very similar thing. Is it behaving in the same way as that?
Okay. The question is the new private link behaving in the same way compared with S3 endpoints or not? And the answer is no. So let's look at how the S3 endpoints, the traditional gateway type endpoints, work. So you establish an endpoint, you try to connect to S3 or DynamoDB, and we ask you to pick a subnet, and you will have a route table entry, additional route table entry to your route table, and you attach that route table to a particular subnet. From there, if you want to call S3, we will route you just differently from the Amazon's internal private network to get to S3. It's essentially a routing decision there. That's why if you have a S3 endpoint in one of your VPC, you wouldn't be able to use it outside of that VPC or from your on-prem networks. It's essentially additional routing in your route table, and that's routed to get to S3 through the different kind of network setup there. However, for private link, now we have a physical elastic network interface. It's a real endpoint interface in your VPC, and you see the IP address and the DNS with that. So that's kind of the difference. And then from that, your applications in your VPC or your on-prem just need to call that local IP address, or just need to call the DNS names that resolves to that local IP address. And that's the way the traffic gets through and get to the other side. So that's the difference. So the short answer is no. The S3 endpoints and the new interface endpoints that are powered by Private Link is very much different. Okay. Any other questions?
Is the service provider, the service that you're providing, is it always internet accessible?
Okay, the question is for the service provider, if you want to provide a service, is that internet accessible or not, right? So for the network load balancer setup here, you can have a network load balancer that's internet facing, and you can have a network load balancer that's internal facing. To work with Private Link, we don't have particular limitation on your network load balancer has to be internal facing or internet facing. It can work both. Let's say you have a network load balancer that's internet facing, and you have your service behind it. It today serves the internet traffic. It works well. And tomorrow, you register this network load balancer with Private Link and register service with that. then you can use that network load balancer to serve the private link traffic from another VPC, from another account. That will just work. You can do just the private one. If you want to set up a network load balancer, strictly internal facing, doesn't take any internet traffic, that's fine. And you can register that NLB to be a private link service, and then you whitelist your customers, and they will be able to just create endpoints to your NLB, and this way your NLB is not taking any internet traffic in this case. Any other questions? All right, if there are no more questions, I guess this concludes this session. Thank you everyone for coming. Thank you for your time. And thanks Scott and Ryan and Eric for your great participation here as well. Thank you.
Thank you.